been having a number of webinars over the past number of years about various aspects of energy efficiency and conservation, heritage conservation. And so today we're delighted to have with us MCW, Purcell and K J Tait to speak to us about a very interesting case study on the Buttery Dining Room Bar and Cafe project at St. John's College in Cambridge. And so I think you'll all be muted and cameras off, please. And if you have questions, please put them into the chat and we'll pick them up at the end. The team will probably speak for about 45 minutes and then there'll be, as I say, time for Q&A afterwards. And so with that, I'm just going to mute and turn off my camera and I'll hand you over to Laura Byrne of Purcell.
Thank you, Edith. Hi, everybody. I am joined here today by Paula. If you go to the next slide, Paula. I'm not driving, so I'm going to be saying next slide every now and again. So I'm head of sustainability at Purcell, who are the world's largest heritage architecture firm specialising in the restoration, conservation and adaptive reuse of the historic built environment. I'm joined by Paula, who's an associate director at MCW Architects, Dan Farrington, who is an associate director at K J Tait, and Mohammed, who's also from K J Tait, and they will each introduce themselves and their roles on the particular project when we get onto that. Because we are here to talk about the retrofitting of our built heritage, and we're going to do that through the detailed look at the project that Edith's already mentioned. But I'm going to first touch on why it's important we don't exclude historic buildings from the retrofit and decarbonisation agenda. So this slide is really to just kind of make sure that we're all talking about the same thing and kind of the definitions are clear to everybody. So the term heritage is defined as all inherited resources which people value for reasons beyond mere utility. So we place values on our built heritage that go beyond cost per square metre, and we impose protections through listings and other restrictions because we value their historic and social significance. The conservation of our built heritage is sometimes seen as a barrier to change and progress, especially when we're talking about retrofitting energy efficiency measures. But the definition of conservation is the protection of plants and animals, natural areas, and interesting and important structures and buildings, especially from the damaging effects of human activity. So conservation in all its forms is about the responsible stewardship of our inherited world, and with that it's intrinsically linked to supporting planetary health and conserving our natural resources. But despite this inherent alignment,
sorry about that.
We can't.
Something else was starting in the background.
Is everybody muted? Just thanks. We can't pretend that it's not without challenges. We of course need to be mindful of the sensitivities that come with listed and historic buildings, but that doesn't mean we can't be ambitious with our historic built environment, even radical sometimes. Next slide, please. There's a report published in 2023 and that highlighted the heritage and carbon skills gap and noted that nearly a quarter of all UK homes and a third of all commercial buildings were built before 1919. And that report estimates that retrofitting these buildings would equate to around 30% of the annual reductions in emissions needed to meet a sixth carbon budget. So doing nothing with our historic buildings is not an option, and doing something requires a collective effort and a shift in attitude. Next slide. So retrofit is a word that we now all associate to mean buildings that are adapted to improve their energy efficiency with a view to reducing carbon emissions. In fabric terms, that's replacing windows, adding insulation, improving air tightness. But the problem with doing this in a building built before 1919, if you go back to the previous slides, sorry, Paula, is that in these traditionally constructed buildings, they perform very differently to modern buildings. So especially in relation to moisture and air movement. They're made of vapor permeable materials which take up moisture from their surroundings and release it according to the environmental conditions. So drafty old buildings may not be very good at keeping in the heat, but this uncontrolled background ventilation helps reduce moisture accumulation. So when you apply layers of vapor impermeable materials like plastic-based insulations or cement renders and reduce that flow of ventilation too much, it can lead to problems of moisture accumulation and cause damage to the existing fabric, cause mold, and lead to poor indoor air quality. So next slide. So it's important to understand how a building is functioning as an environmental system, and that understanding feeds into what is called a whole building approach, one which considers the building as a system of interconnected materials, functions and users, and understands the effect of external and contextual influences. And this is the right approach to retrofit, regardless of the age of your building and whether or not it's listed. Next slide, please. So at Purcell, we've been working with the City of London Corporation for over the last 2 years to help understand the barriers to action across the heritage buildings in the square mile. The square mile is home to over 600 listed buildings, which cover about 20% of their total land area. And the City Corporation has ambitions to get to net zero by 2040 across the city. So they recognise that this isn't an area that they can ignore. So we've carried out extensive stakeholder engagement with owners and occupiers of listed buildings to try and build a picture of what it is that is needed to help facilitate greater action in relation to carbon reduction across the built heritage. Next slide. So in response to the feedback that we collected, we've produced a toolkit which is available to download as a PDF. There is a QR code on the screen for those who want to take a look. If that's not working, you can just type in Heritage Building Retrofit Toolkit into Google and hopefully it's the first thing that comes up. But the goal of this was to provide easily accessible advice and guidance on where to start and to signpost other excellent resources on the topic. The toolkit identifies 8 core typologies of historic and listed buildings common to the square mile, but with relevance outside of the city too. And it acknowledges that there's no one-size-fits-all solution when it comes to heritage retrofit, but there is a common approach. And we've set out a 9-step approach, which is based on best practice principles. I'm not going to go into detail into those 9 steps, but what I will touch on in the next slide is when we're thinking about assessing the opportunities of heritage retrofit. So we've developed this hierarchy which describes how we start from a position of knowledge, and that's about arming ourselves with data about the building, its significance, its situation, its construction, condition, energy use, how it's used, and how it's functioning and performing in its current state. And this understanding helps to develop the options of how you can improve that, but also build a case for change. In terms of significance. So after that, priority is then given to eliminating unnecessary energy and resource wastage, ensuring the building is in good condition and addressing damp, cracks, gaps and other defects before you try and do anything else. Then mitigating the impact of unavoidable energy and resource use through efficient use of space, low energy services, things like that kind of low hanging fruit. Then looking for opportunities to improve the building performance through interventions like appropriate use of insulation and window upgrades. Before finally considering zero carbon and active energy technologies. And that's not to say that that's the least important element or that's kind of last piece of the puzzle. It just helps to have gone through all of the other steps before getting to that one, to make sure that you're using as little energy as possible. And that can also have benefits with reducing the risk of harm to the building's heritage significance. And this is very much an approach that we took at St John's College in Cambridge, which I'm going to now hand over to Paula to talk about in more detail.
Thank you, Laura. Sorry, it took me a while to unmute myself. Thanks very much for inviting me. So I'm Paula Wright. I'm one of the associate directors at MCW Architects, and I led this project, the Buttery Dining Room Bar and Cafe for St John's. It was pretty much a team effort, so that we put the team there. So Purcell and K J Tait are here to talk to you about it too. The project is basically refurbish and also new build project. I'm going to attempt to point. So we have a corner of second court and also a section of third court, which was part of the site. And we also have the Buttery Dining Room, the original one from the 1970s, which was built in an infill, which was the original kitchen lane where they kept all the stores. It also included a terrace. It's a very small terrace, but it's quite significant because it's the only space, outdoor space, where people can sit in the college within the core, historic core of the campus. This is just a picture of what the second court side looks like. So we are exactly here in the corner. And just a little bit about what it entails. So obviously the part of the listed building, which is what we are going to talk about today, in the site only was limited to the ground floor, but we also have some area in the roof where we were going to have all the plant, and Dan is going to tell you all about it. And we have to thread all the services from the roof to the ground floor through the listed fabric, so that's quite a tricky part of the project. The original layout, so we had 3 very distinctive spaces. The dining room, as I said, the 1970s. We also had a bar, which was, as you can see, a little bit dated, but it was really well loved by students and the fellows as well. A section of the community, because some others felt that it was not very inclusive. It was pretty much a sports bar with doors. All 3 spaces had doors to the center hallway where the toilets were. And the JCR, which is the junior combination room, which was basically the undergraduates' social space. That undergraduate space had an internal ramp, which used to take most of the space in the plant. It was quite intrusive, and also for somebody to use that ramp, they needed to call a porter to open the door. So it was not a very great condition. So also the battery dining room was built in the 70s, was not insulated. It was cold. Acoustics were poor. Also, it was very dense. It was a little bit like a school canteen. It needed some revamping. So that's part of what we were asked to do. So the proposed layout and the brief, the college asked us to create a space that was going to be the center of the community. This was the first project of the master plan. So they had a master plan done by Alice and Morrison, I think 2018. And this was the first project. They needed to be more inclusive and need to be accessible. We needed to increase the capacity as well of the battery, because they wanted to have at least 200 seats, and they only had just over 100. And it needed to be more sustainable, and we'll get up to that. So in terms of inclusivity, so we had, and accessibility, so we raised the level of all of the JCR and created new levels on the outside, on the court, so we can access the community hub from level access from the court. And we added a ramp. We also raised the terrace, so basically we have a single level all throughout. And we moved the bar from this area to the JCR section and open up what was originally windows. You can see one here in the corner. Original windows became doors, so we could connect both spaces, and that was our strategy to increase the capacity of the space, because there was no way we could really extend any more into the terrace, the original battery. Go back to Laura.
Yes, so hopefully that kind of gives a picture of the kind of level of intervention that was possible, and I think that was primarily because we'd built up quite a strong knowledge base and really understood the capacity for change. So Purcell were Heritage Architects, and so we carried out a large amount of research, particularly into the historic development of the college, specifically this area that we were looking at archive records and historic drawings and things. Next slide, Paula. There was opening up works and visual inspections carried out. Of particular note, there was a survey of the interior panelling and identified areas of the panelling that were clearly historic, other areas that appeared to be historic but had been reused from somewhere else. But it highlighted that quite a lot of the panelling was more modern, and this helped build a case for change and provide demonstrable evidence for what we decided to do as part of the retrofit of the heritage building, which was insulate the inside face of the external walls. And we're going to come on to that in more detail. Next slide. So all of this information fed into an assessment of the significance of the building, which is graphically captured through this drawing, and there was other subsequent ones as well. And it shows areas of high significance in orange and red, medium significance in yellow, like the kind of ground floor slab area, and low significance in green and blue. So that kind of 70s extension that Paula has already mentioned. So the study concluded that whilst the project is within a highly significant building, the area allocated for this renovation has undergone considerable change in terms of layout, use and built fabric. And like most listed buildings, the site has capacity for further change to meet contemporary requirements, including environmental improvements, provided that they don't adversely impact the most significant spaces. So in addition to all of that collection of data around the significance, there was a lot of research to determine the building's performance, including condition survey and opening up works to verify the construction build-ups. This image shows the thermal imaging survey that was done to understand where heat was escaping from the internal areas. And the survey showed evidence of air leakage caused by openable elements of the windows and doors that do not form a complete airtight seal. You can kind of see that through the different variations in colour there. Next slide. There were U values of the existing walls of the JCR and bar were measured, and that was kind of done in a number of different locations, and the red numbers that you can see on the screen there kind of indicate the range of different results that were taken from those U value in situ U value calculations. There was also an air permeability test that was done to establish a baseline air leakage from the areas that were to be refurbished, and quite a prolonged period of monitoring of relative humidity, ambient temperature and surface temperature over a 12-month period before works commenced, and that was to review the possible environmental impact of the proposed changes on the conservation of the historic fabric and furnishings. So there was a huge amount of baseline data and research that was built up, and that fed into the analysis that K J Tait carried out, which I'm going to hand over to Mohammed now, I think, on the next slide.
Before I pass on to Mohammed, I should have told you before that the reason why we did all this data, so the surveys, the analysis of the historic fabric and all of these is because in terms of sustainability, the college didn't give us a very detailed brief. They just said they want the building to be as sustainable as possible. Initially, as a team, we only thought we could just think about decarbonisation. We didn't really think we could have any improvements to the fabric in being a grade 1 listed, but very quickly realized because of the constraints of the site or where we are, we couldn't really, well, we have some constraints to have like ground source, so we looked at river source heat pumps and all of these renewables, but we very quickly realized we needed to reduce the demand of heat in the space, and the only way we were going to do that was to improve the fabric and the performance of the fabric. So we had some consultations with Historic England, consultations with conservation officers, and then they just basically said, okay, yes, but you have to really back this up with data and demonstrate that you're not, whatever you do is not going to harm the listed building. That's why we stopped the project as a stage 3, and we had a 3-month break where we did embark in this study, which is basically what we're showing you now, about fabric improvements. And we got an expert in Toby Curtis, that is a Historic England person that helped us and analyze the data and kind of gave the seal of approval to our proposals. So I'll pass on to Mohammed, so he's going to talk about the model.
Thank you very much, both. So my name is Mohammed. I'm from K J Tait. I was working on the energy modelling and helping out on the BREEAM assessment for St John's. So what we did is we gathered the information from the surveys, and with the use of the architectural plans and elevations, I managed to create a 3D model of the refurbished areas. And in this case, so this used as a base case as to comply against any sort of proposed upgrades for the future. the building elements that were assigned for the U-values were coming from the survey, but also we used assumed values as well. So this was used from other experience that we have from other buildings and investigations. So if you see on the left there, we've got the U-values that were assumed and from the surveys there. Should be noted that these U-values are only indicative and due to the historic nature of the building. The calculations used to determine the current and future performance of the building were developed for use on modern structures with known materials or predictable performance. The application of these tools to historic buildings can be used and provided using general understanding of current performance and anticipated change. But there are many variables which mean that outcomes can be different to those calculated. Nevertheless, when used with an understanding, the tools can still be helpful in defining the overall impact of the changes. For the model, we used a test reference weather file to calculate the weather conditions and to provide the annual heating output there, which is seen on the right-hand table. So if using a daily profile between 9 AM and 10 PM and using a set point of 21 degrees, a peak zone heating consumption and an annual heating energy consumption was calculated by the software. It should be noted that the model is a simplified version of the existing building and should not be used as an indication of the actual energy consumption of the whole building. However, these results were used as a basis of comparison against proposed fabric improvements. Next slide, please. So here we see that we used quite a variety of different separate models here to compare against a base case. So 6 options were created via the use of the IES software to assess the potential reduction in annual heating loads, the energy consumption, and its associated carbon emissions. So as displayed within the table, we used different sort of options, replacing the glazing to provide a better thermally insulated performing option. We also used options where we could insulate and better the facade with the aim of better thermally insulating envelope, and even a combination of all separate variables as well. So as a team, we investigated as many feasible routes as possible to obtain the best course of action to provide the best reduction in terms of annual energy consumption. Next slide, please. Choose the heritage of the building. Sorry, just one back, that's it, thank you. Choose the heritage of the building. There are limitations of how much can be altered and can be changed. So to further narrow down the best practical way of reducing energy demands, various glazing options were looked into. Obviously, these can have thermally thermally improving aspects to it, but it's also other aspects outside of it that could be visual and maintenance, etc., etc. So replacing a whole window system cannot also be kept in line with aesthetics as well. So this was a parameter that we looked into in choosing the best approach. The secondary glazing was an option that we did look into, which obviously helped out with the overall U value of the glazing system, but created a negative impact on the view out and the daylighting, which in turn did not help with achieving certain BREEAM credits. The next slide, please. So from the various modelling options I showed before, the data was collected to observe the comparisons against the base case of the existing building. So if you see the graph on the left, which shows the peak heating loads for the existing bar, cafe, and WC areas, you can see that model 3, shown in the grey there, provided the best overall reduction in terms of the peak heating demands, and of course with the carbon emissions as well. This was closely followed by options 4 and 7. It was seen that the impact of replacement of the windows was less than the improvement of the fabric. This is primarily due to the wall to glazing ratio. Therefore, it was concluded that the best route forward was to go for the option 4, which was using fabric upgrades to the wall and to the floor, but also using Histoglass, which is a thermally improved single glazing pane system, which also keeps in line with the period of the building. So with that, I'll pass you back to Paula.
Thanks, Mohammed. So I'm just going to highlight what the improvements that we did. So we had in the purple, all that area had a concrete floor that was also added in the 1970s. All the concrete floor was removed and we replaced it with a limecrete slab that was insulated with the recycled foam glass insulation. The areas in blue were raised timber. Obviously, as I said earlier, we proposed to raise all the floor to have one single level. So we suspended a new timber floor above the existing. So we kept the originals underneath, and that suspended timber floor was also insulated with wood fiber. All the external walls, all the areas with the yellow line shows where we had wood fiber insulation on the walls. And as Mohammed said, so we changed the glazing of the windows, and that after going through all the options, I think Histoglass was the option that was acceptable to the conservation officer and Historic England. We would have liked to gone for double glazing, but obviously as we were only refurbishing a small area of the building, we couldn't really get permission to do the windows as well. So we have to keep it to single glaze, but improve the thermally. Apart from the walls and floors, we also have to bring back, so because we are making the space, the changing the environment of the ground floor, we had to separate that by insulating the ceiling. So we basically created a box in the ground floor. So that was so we didn't want to affect the environment of the floors above. We have some precious wall paintings, wall frescoes just above the side. So it was critical that we didn't change the environment. And as I said earlier, we also had to bring ventilation, so mechanical ventilation, so change what was the historic ventilation through leaky fabric. We need to replace it with mechanical ventilation. So from MVHRs in the roof, through risers, through the building, and distribution under the floor. On this picture, you can see some of the insulation for the linecrete, so the recycled foam glass, the glass board, and there is also, you can see there's the ducting, so we have to have the floor trenches, and those are kind of the sections where Dan is going to explain exactly how the floor ventilation worked. Wood fiber, as I said, on all the external walls and the windows were changed with Histoglass. So it's called Mono RT Plus Histoglass. So it's only for milled, so it fits in the existing frames. The existing frames were bronze frames, which were repaired. And the U value of the glass, it was improved to 3.6, which is not great, but it's much better than a single glazing that was between 5.6 and 5.8. So I'll pass it on to Laura, I believe.
Hi, yes, I was just going to note with this slide, I suppose one of the benefits of the Heritage approach to retrofit, some of the products mentioned, that they are kind of bio-based products like wood fiber insulation, and that kind of contributes to lowering the embodied carbon overall of the project, and so that it is something that we're kind of cognizant of, as well as the operational carbon. That's what I wanted to say on this slide, and I think Dan's now going to take us through the services strategy.
Hi Laura, thank you. So I'm Dan Farrington. So I was the MEP lead on the project right the way through. From our perspective, I guess the service strategy, there were some sort of fundamental key principles in the design. With it being a historic building, we wanted to keep the services hidden from sight throughout both the listed and the new build elements. We wanted an exemplar low energy building, I think has been covered through the modelling that Mohammed took you through. And also we wanted to have an integrated design approach. So we wanted the services, structures and architecture to work together to give us a warm, welcoming and comfortable space within the new area. So within the battery diner, which is shown here, so the strategy was really for a displacement ventilation, which came in through low velocity grills at ground level, as shown in the image here. During the winter, these would work with an extract fan at high level above the servery area, so we would pull air out, avoiding the smell sort of permeating further into the building and the adjacent spaces. In the summer, we had a mixed mode approach, so effectively we could utilise the big roof lights that could open up and allow us to purge, ventilate any hot air using a kind of stratification approach. We could also open these overnight to offer some night cooling, where we would cool down the existing structure of the building and also the new floor slabs. We use underfloor heating throughout the whole building, where basically we could provide radiant heating to occupants. This worked well with the heat pump system that we came up with to give us a low carbon footprint. But future climate, we also put in some infrastructure for cooling pipework to add heater batteries, or rather cooling batteries at a later date, should they be required, to give us a bit of climate mitigation. There was also a rainwater harvesting strategy from the existing roof, which was collected and then used to fill the biophilic wall that's shown here in the image. Next slide, please. So this one really takes us through the wider strategy in the building for the ventilation. So as Paolo mentioned, we've got an MVHR that's serving some of the WC blocks that are being newly created, and an AHU with a thermal wheel that was used to serve the cafe and the bar areas. The only area that had any cooling was the bar cellar, which is shown in the dark blue, which was really just to give us a much cooler space to store everything, all the drinks. If we purge through these, then Paolo, if you can go on the next one. That's it. So the extract, effectively, they were again taken at the point in the cafe and in the bar, again to kind of take the smells away. To keep the services hidden, we used one of the chimneys were repurposed to run a duct from the cafe up to the roof level, and then it ran through the roof void back to the main air handling plant. We had a kind of common return arrangement to the open plan between the cafe and the bar area. And then also we had for purge ventilation, go to the next one. That's it, brilliant. We got obviously the existing windows and the turrets within the new build area. So these could be utilised by people sitting in the spaces as and when they felt necessary. For the winter situation, it's a fairly similar setup, full mechanical ventilation throughout, bringing the air into the building and taking it out again. So next one. Brilliant. So a very similar setup. Obviously, this time we don't have the purge ventilation, but we have the addition of the heat source, which I think you can see there is labelled as kitchen lane. If we do the next one, which provided all the heating to the building, so underfloor throughout. We also had some radiators, which I'll talk a bit more in a minute. Next slide, please. So low zero carbon measures. I think Paolo mentioned earlier we had a few options open to us. The first one we looked into was making use of the St John's Meadow in the adjacent space. The white square here shows that the kind of area we might have needed to feed the building's heating supply. However, I think we looked whether we could then expand this further to do the heating to the rest of the buildings across the site. The second option was to look at the river. You can either do an open or a closed loop system. We looked at both possibilities. Both were fraught with fairly tricky technical problems. The river camp's fairly shallow. It's a popular spot for punting, so that in itself brings about several challenges that would also add complexity to the project. Then the chosen method we ended up going with the end was air source heat pumps. So as we said, these were down the kitchen lane, and they're shown here on the right, where a precedent had already been set for heat pumps to sit. Next slide, please. So yes, as I mentioned earlier, we had some radiators. So under the existing windows, those that had the Histoglass added, we were still concerned about potential drafts that were created from this, much poorer performing fabric with a big cold stone. So in winter, you might get a downdraft coming onto the occupants. So to offset this, we did hidden heat emitters that were put into these kind of boxed out recesses that were located behind the seating areas. These had a remote TRV that basically measured the air temperature around sort of head height of the people shown here, and would allow these to come on and off as required during sort of colder periods of the year to give us a warm air curtain to keep the space nice and comfortable. Next one, please. So we talked a bit about rises through the building. So obviously, previously there was very limited service distribution. Now what we had to do is get sufficient air in to look after all of the occupants. So carefully, we threaded up a whole new riser from the ground floor up through the bedrooms, which had to be carefully considered. So it sat directly behind the panelling, I think, shown here in the middle and the upper image, such that the maintenance could be completed from below and above, and there was no disruption to the fabric on the intermittent floors. And again, for future access, if these were occupied spaces, it would make things a lot more easier. I guess the other challenge was it needed the riser needed to be completely fire rated to maintain the compartments between the floors, and it also needs to be able to remain self-standing in the event of a flyout on any level. So that was quite a big challenge. Next one, please. Once we got the air down into the spaces, we had to think about how we could distribute it into the rooms without minimal intervention to the aesthetics of the building. As Paula mentioned, this involves some fairly significant excavations to some of the areas here. You can see a trench on the left where we literally dug up the floor to run the vent around the perimeter of the building. And then where there were suspended floors, we simply run the services underneath. We did this for all primary services, so the power, the water connections, and all of the chilled and heating pipework, which then popped up into various other areas. So we go, great, thanks, Paula. The cupboards and final distribution here, so you can see we've got somewhere to accommodate all of the new electric panels and underfloor heating manifolds. So these were kind of discreetly integrated into the kind of layout of the spaces. Then we also had a kind of final level of services. So on the top layer here, you can see some of the pipework and the trunking, running floor boxes and power going across, which sat within the installation level before the final floor finishes were put on top. And so the finished effect was this. So the kind of a wooden floor went down. You can see in the central picture there were these rather large rectangular boxes which contained a linear diffuser which would kind of discreetly put the air into the space, but at quite a high velocity to get the air volumes in. And these had to be very carefully coordinated with all of the furniture layouts to make sure that they remained clear of obstruction at all time. But this gave us a fairly minimal visual impact for the vent. For the new build element, so it was a bit easier here. We had a service path down the wall of the existing building where we brought in all of the power, the rainwater was collected, the heating pipes and all of the ductwork, and that sat behind the kind of biophilic wall here, which allowed the services to come into the space without being seen. Underfloor heating was used again. The buttery had a lot of chill containers that needed refrigerant pipework, and they were located in the middle of the spaces. So we had various channels between the sections of underfloor heating to allow the distribution of these across the floor plate. And then so the plant was always a tricky one to accommodate in any historic building. We often find that roof spaces are a great place to look at, although they still present their challenges. Often they're empty and they offer a good opportunity. As was the case here, we managed to locate both the AHU and the MVHRs in the loft. This wasn't without any intrusion. We did need to put in a new larger loft hatch to give us full access to both get the plant up and give future maintenance access, and also the areas need to be fully boarded out. But here you can see the kind of gymnastics we had to do with some of the structure to support one of the AHUs. And then in the middle section, you can see some of the ventilation that had come back from the chimney. On the buttery diner area, there was an area of the roof that was set back, so it was out of line of sight from the adjacent bowling lawn Trinity, with plant already precedent already set for plant there from the kitchens. We managed to tuck them away, and then these were kind of fully screened off, such that they had as least the impact as possible on the surrounding building. And that's it for me. Thanks. Any questions?
Thanks, everyone. Edith, I think that's we've covered everything we were planning on covering, so we can open up the floor to questions now.
Great. Well, thank you all. I think it just shows I think you've given us a really wonderful multidisciplinary presentation that touches on all the key aspects and really shows, the attention to detail and the coordination and all of these things that are needed to make one of these projects successful. So there are a few questions now beginning to arrive in the chat. So first one from Hannah Jones, Green Gauge. How were the requirements of BREEAM and consideration of moisture and thermal bridging balanced when looking at fabric strategy? How did you quantify the impacts of thermal bridging in your model? I assume only IES was used. How did you assess the risks of thermal bridging and moisture risk in your decision-making of fabric improvements? How much wall insulation and where this went? Moisture and thermal bridging can create considerable risks with respect to historic buildings. Did you work with Historic England to justify your material decisions? What evidence did you have to provide? So that's a very long and detailed question from Hannah Jones. So I don't know who would like to start first. Mohammed, is it you're going to talk about the thermal bridging? Yeah.
Absolutely, yeah. So in terms of the BREEAM and the thermal bridging, so we do actually use another calculator tool to calculate the thermal bridging, which is used then in IES as a part figure there. So that part was taken care of. In terms of BREEAM, obviously, when it comes to energy reduction, that is key, especially when it comes to refurbishment and fit out projects. So trying to maximize as many credits as possible there, which I think for this project got a very good excellent for the new building and very good for the refurbishment areas. So yeah, so that's how we dealt with that matter. In terms of the thickness of the insulation, I cannot remember off the top of my head. Maybe somebody else can help me out with that.
So I was going to say, Hannah, so we work with David Curtis, who did all the modeling for the moisture for the building, and he also the college commission monitoring of the fabric before for a whole year and after construction for the whole year. So just to demonstrate that we haven't done any damage to the building, and that's all come back as very positive, which is great.
Great. Next one from Alexandra Williams. Was any consideration given, in addition to the rainwater harvesting, to reduction in water usage on the basis of the carbon impact of the processes that facilitate mains water supply? Is that one for you, Daniel?
Yeah, so I think obviously it was quite a constrained site, so the limitations of that stopped us from perhaps putting in a larger scheme to offset toilet flushing and so on. I think what we had to do was underneath the service yard, we had to bury a pretty small tank, and that was only sufficient to actually feed the biophilic wall. So that was a feeder, and then there was a secondary tank. So yeah, we weren't even actually taking the water off this roof, so it was coming off the main roof. It was re-diverted down. But yeah, so unfortunately that kind of limited us a bit. But it was quite a bit of water that the green wall uses. So I think we didn't worsen the problem.
And are they, I mean, in terms of I suppose all the facilities, the kitchen and the catering, I presume the sanitary ware is as low water use as it can be.
Yes, exactly.
Yeah.
So we got all the BREEAM credits for sanitary. So there was only 6 toilets. So that was the reason why we couldn't really use rainwater. There was quite small requirement, and we didn't change any of the kitchens. So that was outside our scope.
Okay, thank you. Now the next one. Let's see, there's a cost question. There's always a cost question. So D Nunn, I think, are you able to share any cost information?
Unfortunately not.
No. Okay.
But we can say we weren't within the budget of the college, but it was a generous budget. It was a difficult project. We found obviously once you start working with a listed building, there's a lot of things that we found during construction. There was not a lot of records, so there was a lot of instructions. Luckily, we had a good reserve fund, so yeah, that's all we can say.
Very good, thank you. Now, there's another one here, Hannah Cates, I think. There are a lot of guidance documents published by lots of different organisations for the retrofit of traditional historic buildings that include whole house approaches. With so much out there, what did you rely on when creating a methodology for this project? And do you think the sector needs a single guidance document? Who would produce it? BSI, PAS don't feel very accessible when trying to explain the benefits of whole house approaches to homeowners. Laura, is that something that maybe you might comment on?
Yeah, it's a good observation, because we certainly found when we were working with City of London, we did a kind of literature review of all the available documents, and that was some of the feedback that we got back from when we were talking back to owners and occupiers, was the kind of almost there's the danger of there being almost too many different resources, and some of them contradictory, some of them are kind of perhaps too complicated, some of them put people off because it sounded like it was not really worth it, that it was too difficult to approach. So yeah, it's certain. And with the Heritage Building Retrofit Toolkit, what we've tried to do is just kind of pull from the kind of key resources and signpost to them, rather than just duplicating something else that is going to be another thing for people to read. It's just signposting the key information. So we did try and distill that in that. So do have a look, and if there's feedback on it, then let me know. But I guess for this project, I think because Paula, you can probably talk to it more, but because it wasn't necessarily like the key driver for the brief, the brief was just be as sustainable as possible, wasn't it? So it was really kind of you guys, the design team, sort of pushing that element as far as possible, and then working really closely with Historic England and on how best to justify those measures and kind of put forward a case for change. And I think it was that really detailed bit of research that Paula said, took 3 months out of the programme to do all of that background investigation to help. And it was a kind of specific standalone report called Fabric Upgrades or something similar. And it was just putting forward that case and setting out, how much energy is being wasted through the building fabric already, and how these measures are not going to be significantly harming the heritage aspect of the existing building. Do you have anything to add to that, Paula?
Yeah, no, I was just going to say, as I said, obviously we started this project in 2019, and that's now 5 years. I think we would have done things differently or approached it differently from the start if we started today. There is a little bit more thought into, like at that time, we didn't think it was even possible that we could upgrade a grade 1 lister, and that's what we didn't think about it to start with. Hopefully it's not the case anymore, and conservation officers and Historic England are now more open to upgrading the listed stock, because we're going to have to. The climate is changing, and we have so many of these old buildings. We need to improve them. So yeah, that's it.
And I think the thing that I'd add to that maybe is just that through forums like this and kind of sharing different examples of talking about where it is being accepted, I think definitely adds to that narrative and gives people confidence and a bit of ammunition almost to just test it and see how far you can push these different measures. We're certainly finding that the more we talk about the different things that we're coming up against, the different challenges, where we have got things through and where we haven't, I think it definitely, people appreciate having that as to help inform their own projects.
Great, thank you. Okay, we have probably 2 building services questions which I can run together. So James Corns has asked, out of interest, why did the ground source not get explored further for the MEP heating and cooling strategy? And then there was another one in regards to the M&E cooling plant that were installed on the roof. Did you have to encase them from being seen from above? That was from David John Pitts. So I don't know, between Daniel and Mohammed, maybe you could pick up on those.
Of course, yeah. So for the ground source, I think really it was the matter that it was going to be much more widely disruptive to the college, to get across from the lawn, across to the other side, was going to involve a fair amount of digging. We'd have to run the pipe work either below ground or over the bridge. I think given the budgetary constraints, we were really quite tied to working in that area of the site. We did talk about a wider heat network, and that was something they were looking to develop at the time. I think the problem was that the project here was meant to set a benchmark for the rest of the site, but not. The brief wasn't to actually look at the wider site and the distribution, and that was a piece of work that was to follow on. We did get as far as exploring plant space, and we'd found some good areas for them. But I think the disruption and cost were probably the key reasons. Perhaps that's something they'll take forward in the future.
And did you have to hide the MEP plant from above? There was a question, or is it all fitted within? It's all fitted within the roof line, is it?
So we have, we had panels, vertical panels, so enclosing it so you couldn't see it from Trinity. We have to demonstrate with CGIs that it couldn't be seen from any of the windows and Trinity. Obviously, Squire Secluded side is the only sidelines that you have is the college next door. You can't see it from the river or anywhere else. But yes, the sets above, they can see it. It's open at the top.
Yeah, but there was already plant set there for the kitchens that are directly beneath, so there was sort of precedent set.
But it's next to our lovely copper roof, so it's fine.
Very good. There's two questions I think about has any post-occupancy study, or analysis or monitoring been done, and how has the building performed against predicted energy use?
So we did do a operational energy assessment during the design period. So we are waiting for a full year analysis, so information to come back from the clients. So we can assess the design against the post-construction and see if we're in line. Are they consuming a lot more than predicted? So watch the space really to see how well they're performing.
Great. We'll look forward to the next session on that. So there's question about the wood fibre. Maybe, I don't know, Paula or Laura, are you able to answer about the thickness? And then does the Histoglass really work outside the lab? When Pilkington's tested hard-coated single glazing, it lost performance when it got dirty, so they stopped selling it for primary glazing. Though work with UCL showed that it was better for secondary. That's from Bill Bordas. Hi, Bill.
So we use 80 mil wood fibre in all the external walls, I believe. Histoglass, does it work? I can't answer that question. I don't know. We hope so. It is. If people feel comfortable in the space, we have got no way to say unless just that people sit by the windows and they're happy.
We'll have to make sure they keep it clean. Seems to be maybe part of the message there, which I'm sure would happen.
I guess I would just add on the windows as well. It wasn't necessarily the only option that was considered. There was kind of one-to-one mock-ups of double glaze, like slimline double glaze units made and compared, and there was secondary glazing. Mohammed's already mentioned the challenges around getting that to work from an occupation point of view, and kind of concerns around condensation as well. So there were other options, and it was just, I think, part of that process of going along, agreeing with Historic England, the Conservation Officer, and the college as well, all kind of seeing seeing this as just one part of a holistic quad, and the kind of heritage value of seeing of that quad being read all together. And if you fundamentally change the windows and one small element of it, how would that impact the rest of it? So it was kind of there was a lot of things to balance there. So I think it as Paula mentioned, it's kind of it's the priority is that people feel comfortable in the space and the energy use is down, and we'll see if there's any kind of
and at the end of the day, it's quite slow percentage of glass to wall.
Exactly.
So the impact was low, as we could see in Mohammed's models. So it would have been slightly better if we have double glazing or secondary glazing, but the secondary glazing had other issues like moisture and cleaning, and obviously in terms of the conservation was not the best of the solutions. So we were kind of in between double glazing and the histoglass, and the Historic England and the conservation officers will prefer the histoglass, and that's what they accepted.
Okay, now back to the MEP. So where you repurpose chimneys as mechanical ventilation paths, did they need to be lined? And if so, does this cause any issues with permeability of the chimney construction? That's from Ian Hughes.
Hi, Ian. Yeah, so yeah, I can answer that one. So yes, the chimneys were lined. So I think we had to look at a whole host of different possibilities, and in the end, we ended up going with a kind of balloon-like structure. So effectively, a sock was inserted into the chimney. These were then heated up and expanded to fill the chimney breast. I mean, the chimneys are fairly well set in to the building, so I guess on the inside aspect, there's still a permeate path around the chimney. So we didn't consider that was going to pose us any issue. But obviously, trying to get the air out through the chimney was quite challenging.
Great, thank you. There's another question from Bill. Obviously, we've said we're not speaking about the budget per square metre, but there's a note about whether it was possible to estimate any increment related to carbon saving measures. I suppose that's a question about, yeah, whether the budget was kind of increased to, I suppose, to allow for whether it's either BREEAM or other carbon saving activities over what you might expect in a, I don't know, a standard project before we were trying to save carbon.
I don't think we had to increase it. It was set from the start. So we had target of BREEAM excellent for both the new build and existing. So we have two different assessments. And so that's what we had from the start in the cost plan. So we didn't have to increase it.
Great. Okay, now we have 3 minutes. There's lots and lots of questions, which is great. I don't know if you guys can kind of take a look through as well the questions, if you're able to see them in the chat, and just see if there's any, but we can always answer any afterwards that we don't get to. Now there's a question, what is the view on the damage the wood fibre insulation fixings can do to the stone and perhaps brick walls? Laura, is that one for you?
Yeah, and we've had this come up on other projects as well, and I think again, it's a kind of judgment of the significance of the wall and what kind of fixings you use. There's different things that you can do, and then I think the other thing to consider as well is the thermal bridge of that fixing. And so I think it just comes down to a judgment, and I think in this instance there was already paneling on the walls, there were already things that had been fixed onto the walls. So yeah, I think in this instance it was an appropriate solution.
Yeah. There's one here from Alexandra Williams, which is saying that for projects maybe that don't have such a generous budget, what interventions would you advise as the best monetary value for achieving high impact in decarbonisation?
I would go back to that kind of hierarchy that I mentioned right at the beginning, personally, and just kind of work through that. So it seems very rudimentary, but I guess having a building that is well maintained and performing as it should and doesn't have lots of cracks and gaps and damp walls and things will have an impact on the energy efficiency of the building. And so that's a kind of fundamental baseline. And then looking at ways that you can kind of minimize your energy use through the way that you're using buildings, and making sure that you're using, have you got a strategy where all the heating is on all at the same time, or can you just turn things on as and when you need to? And it's kind of looking at those sort of easy wins in the first instance and seeing where those savings can be made. And then I also would always suggest that where you've got kind of anyway expenditure, because you've got like a roof that needs to be resurfaced at some point in 5 years' time or something, or your boiler's coming up, is going to be out of date and needs to be replaced, and it's kind of trying to fit in measures around those things that you're going to have to be paying for anyway as part of the kind of ongoing maintenance. And so it's all about kind of framing. Obviously this was a particular capital expenditure project that the college budgeted for and saw it as part of a wider master plan strategy. But if you without that, it's kind of what other mechanisms have you got in place already and budgets that you can kind of tap into, and usually it's around kind of maintenance and sort of just general upgrades to the building.
Great, thank you. I see just one other one here, maybe Mohammed, for you, maybe then we'll have the last one. There was a second one too. 35,000 kilowatt hours a year sounds like it would be quite a small percentage of the overall college annual energy demand, which I'm sure it is, as even the space is quite a small amount. Is the choice of air source heat pump expandable for any future works?
So the 35,000 kilowatt hours, so that's just for the refurbished area. Obviously, there is the new build area, which has the canteen as well. So that was taken into account for the overall design system. Dan, you probably want to jump in for this one in terms of the expandable assessment for air source heat
So
pumps.
we looked at putting in a wider heat network that I think we mentioned earlier for the ground source, and I think that offered the best kind of opportunity to facilitate all the buildings on the site. So as it was carried out in isolation, I don't think that there is some more space down in that area where we could put in future heating links up, and they could link into a wider heat network. So if the ground source does go in at a later date, but I think that's fairly limited for the air source. But that's not to say it couldn't be part of a wider distribution network at a later date.
Okay. I'll just ask one last question, which is interesting. Was the project delivered with a traditional contract, and was there lots of time given for coordination and detailing in REBA stage 4?
Yes, it was
time.
It was traditional, and yes, never enough time. It also, it was worth mentioning, this was all through COVID, so we have to halfway migrate to working on Teams, which in a way worked quite well. We all learned to share our screens and solve all the problems of looking at our models and photographs, but it was hard because there was not a lot of opening hours we could do during the period as well. You always want more time to coordinate.
And I see someone looking for more information about the project. I don't know if there's anything published that you might be able to point at, but with that, I'll stop there, because we've kind of come to time, and you've all worked very hard. Daniel, Mohammed, Paul, and Laura from K J Tait, MCW, and Purcell. Thank you so much. That's been a really informative and very, very interesting case study, and well done to you all, and congratulations. It's a really successful project that seems to have delivered great value for the college against their brief. So, and thank you from the CIBSE Retrofit in Heritage Committee to everybody who has joined, and for all of your questions, and hopefully we'll see you again at the next one. I think on September 19th, for people who are in the Retrofit and Heritage Committee, we're going to have another kind of open forum at 12:30 on the 19th. It'll be advertised through the usual channels, and that's a forum where people can come on with any questions and any thoughts that they have on this hot topic of retrofit and heritage. Okay, with that, thank you again, and have a good afternoon, everybody. Bye.
Thank you.
Thank you.
Thank you.
Bye.
Take care. Bye-bye.